Welcome to this lecture 22nd. So, we will continue with the groundwater pollution. By industrial sources. So, we have discussed the liquid wastes and tank and pipeline leakage yesterday in the in the previous class, and in this lecture we will continue the discussion and we will go over to that is pollution from mining waste and oil field brines. So, in this pollution from mining waste, so basically it depends upon so this depends upon the material extracted. So, this coal, phosphate, and uranium mines. So, these are the major contributors for pollution. And iron, copper, zinc, lead mines. So, these are quite important. That is other important contributors. And here, so the quarries of stone, sand, gravel quarries. So, they are less important chemically. For the simple reason that, so this stone, sand or gravel, so they are chemically stable compounds, so therefore, they are less important. And coming to this coal deposits, so coal deposits result in are associated with pyrites. Which is essentially it is ferrous sulfide. and this, when this pyrite FeS2 or pyrite oxidizes, due to low water table. So, this FeS2 as such is quite stable, chemically stable. So, when the water table is quite low, then this FeS2 or pyrite oxidizes to ferrous sulfate and sulfuric acid. And these two, this ferrous sulfate and sulfuric acid, so they are the one which cause the pollution. So, this ferrous sulfate and then sulfuric acid will reduce pH, because both of them are this sulfuric acid is after all acid and ferrous sulfate is salt. It is also acidic. The solution is acidic. So, therefore, they will reduce pH and increase Fe as well as Fe plus 2 or plus 3 as well as this SO4 minus 2, the sulfate concentration, and hence pollution. So, therefore, this pollution from mining waste is important. Now, let us go to the next, the last one, that is the pollution by oil field brines. So, these brines include sodium, calcium, ammonia, boron, then chloride, sulfate, trace metals, and total dissolved solids. So, basically brine is the saturated solution of a salt of any of these, either sodium, calcium or ammonium, boron. And here, so earlier, so this brines used to be discharged into streams or evaporation ponds. So, but presently So, this is prohibited by law. However, so because the implementation is not proper, since implementation is weak, so this brines do pose a problem, and in this context pose severe problem of pollution by increasing the concentration of the metals or the salts of which the brine is composed of. So, now we will move on to the groundwater pollution from agricultural sources. Again here let us consider the effects of agricultural use of water So, here what happens is when the water is used for agriculture, and in fact it constitutes quantitatively it constitutes the major use. So, it may either go as agricultural solid waste or it may join the atmosphere through evapotranspiration or which is abbreviated as ET, or it may go as an application of additives, or it may go as tailwater, which eventually joins the agricultural return flow. So, this agricultural solid waste, they may move on to sanitary landfills, from this sanitary landfill the solid portion may move as a leachate and the gaseous portion may get released as gases. And here this one, when this agricultural water discharge gets discharged into atmosphere through evapotranspiration, it may cause soil reactions. And so, these soil reactions, so basically part of it may saturate the soil and then it may percolate into groundwater. Groundwater percolation, while this application of additives, so this will result in say changes in soil zone, so in this case, so these additives may be this soil amendments or fertilizers or pesticides, and so they may also percolate into the groundwater. And the stale water, which is which may get into surface water, and then from surface water it may percolate into groundwater, and or it may go to oceans. So, this is how, of course, so this is also, so this diagram is also from the same source, that is a study by Hassan in 1974. So, wherein the effects of agricultural use of water have been nicely depicted in a flow chart. Now, we will discuss the various components within the which cause the groundwater pollution from agricultural sources. So, they are irrigation return flows, followed by animal wastes, followed by fertilizers and soil amendments, followed by pesticides, insecticides or herbicides. And herbicides. Now, let us discuss these subcomponents of the groundwater pollution from agricultural sources one by one. So, firstly, the irrigation return flows. So, these irrigation return flows constitute approximately 1/3 to half of the irrigation water. Essentially, the irrigation water which does not undergo evapotranspiration will appear as irrigation return flow. And here, so these irrigation return flows, so what they do is, so they increase the salinity and thereby increase in the concentration of so the cations, and it has been estimated. So, this increase in salinity of water. So, that is, it has been estimated as it is 3 to 10 times. So, there are this increase in the concentration of cations such as sodium, magnesium, calcium, then these are the major one, whereas anions are say chloride, nitrate, then sulphate, and bicarbonate. So, because of this reason, especially due to the increase in the salinity of water by 3 to 10 times. So, these irrigation trend flows are very important. Now, let us go to this animal waste. How this animal waste will cause or will increase the pollution. So, here wherever the animals are when animals are confined, when say large number of animals are confined to a very small area or a small, that is limited area, either for dairy production or say milk production, or for beef production. So, large amount of wastes are deposited on ground. So, these large amount of waste, when storm water runoff comes in contact with waste, it results in groundwater pollution. And this groundwater pollution may be in the form of salts, organic loads, and bacteria. So, therefore, we need to focus we need to consider this groundwater pollution from animal waste. Nextly, we will come to the fertilizers and soil amendments. So, these fertilizers and soil amendments usually leach into groundwater and leach through soil to the water table. Which is generally abbreviated as WT. And obviously, the fertilizers, so they are mostly consisting of nitrogen, phosphorus and potassium. And among this, so this phosphate and potassium and this potassium fertilizers generally do not cause pollution. However, so this the nitrogen is the primary pollutant from fertilizers. So, now coming to the soil amendments. So, the soil amendments consist of lime, gypsum, sulfur, applied to modify physical or chemical or physiochemical soil properties. So, they eventually leach into groundwater and increase salinity. And the last subcomponent of the groundwater pollution from agricultural sources is through pesticides, herbicides and insecticides. So, the presence of these pesticides, herbicides and insecticides increases toxicity of groundwater and reduces potability. Even if they are in very small quantities. So, therefore, we need to account for the pollution caused by this pesticides, herbicides and insecticides. So, these 4 subcomponents, that is irrigation return flows, animal waste, fertilizers and soil amendments, as well as these pesticides, insecticides and herbicides, they constitute the pollution caused by agricultural use of water. Now, let us come to the last source of the last major source of pollution, that is the groundwater pollution from miscellaneous and other sources. So, here we will consider the effect of urbanization and how it results in groundwater pollution. We will consider the spills and surface discharges, stockpiles. We will move on to septic tanks and cesspools. Followed by this roadway dicing, followed by saline motor intrusion, then interchange through wells, and lastly the surface water. Now, we will briefly consider each one of these one by one. Firstly, we will go to this urbanization. We know that, so in this urbanization, changes the land use pattern on vast lands and so eventually leads to change in groundwater quality by recharge into aquifers or discharge into streams. And it has been found that this urbanization in many cases leads to increase in nitrate, chloride, dissolved solids, that is the total dissolved solids, sodium, calcium, potassium, especially in young and shallow waters. Especially in young and shallow waters. So, now let us come to the groundwater pollution caused by spills and surface discharges. Especially in these liquids which are discharged on the surface in an unregulated or uncontrolled manner will result in lot of degradation of groundwater quality. So, that is unregulated discharge of liquids leads to groundwater quality deterioration or degradation. So, in industrial sites, we may have boil overs, transfer losses or say losses during transfer or transportation, transfer of liquids, pipe and valve leakages, inadequate control of storm water runoff and wastes, also so the washing of aircrafts with solvents, can cause a hydrocarbon layer. So, that is additionally this intermittent dumping of fluids near gasoline stations, gasoline or say petrol stations, etc., leads to groundwater pollution. And lastly, it is the accidents involving pipelines, storage tanks, railway wagons, oil tankers, etc., results in groundwater pollution. Obviously, the spills and surface discharges, they constitute one of the major sources of this one, groundwater pollution. So, now let us move on to this stockpiles. So, the solids stored near industrial plants, construction sites and large agricultural operations constitute these stockpiles, what are known as stockpiles. So, when precipitation, say suppose this is a stockpile, so when precipitation falls, so this is the precipitation, when it falls on the stockpiles, then the stockpiles will cause leaching, it causes leaching. So, this is a stockpile. So, it causes this is the leachate and it flows into the soil, and so this leachate may contain heavy metals, salts, other inorganic compounds, and other organic compounds. So, they will result in this groundwater pollution. Next, we will go to the groundwater pollution caused by septic tanks and cesspools. A septic tank, so this is a watertight basin used to separate floating and settleable solids from liquid domestic sewage. So, suppose, so this is an individual house, and here from this individual house, so there could be a pipe leading to the septic tank, and then, so generally what happens is, from the outlet pipe of the septic tank, there will be a distribution box, and this distribution box followed by a tile field. So, this is a tile field, and here, so this is under the tile field, so there will be soil absorption, followed by this will be over and above this biological treatment, layer, and there will be so this could be the water table, and here when this the septic tank moves and it reaches the water table. So, there it is it constitutes the zone of groundwater pollution. So, we will briefly discuss this cesspool. This cesspool is essentially a large buried chamber with having porous walls which are designed to receive raw sewage, receive and percolate raw sewage. So, obviously, this septic tanks as well as cesspools. So, there will be percolation and result in the groundwater pollution. So, in the next lecture we will discuss about the further further components of the groundwater pollution caused by agricultural sources, and move on to the attenuation measures for groundwater pollution. Thank you.